Hey musicians, so I want to just introduce some science for you as a precursor to studying music theory. So you're going to study a little music theory as you go through the process of learning to play guitar or piano or using your voice or whatever. And so there's some basics that we can all sort of understand. So let's start with some science and talk about how sound works, because that's how we have organized our music, all right? So you're looking at a keyboard, which is sort of the easiest way to think about these things, and I want to talk a little bit about this stuff. So sound. Here's how sound works. This is weird. I feel like I'm on Sesame Street and I'm a puppet. I don't know why. So okay, so the way sound works is it's a wave. That's a physical thing, right? You can't see them, but you can perceive them with your ears. And what happens is, if I were to sing just a note, like hold that note, your brain is perceiving that as one continuous sound, but it's not actually one continuous sound. Your eardrums are actually picking up that sound like this, and then your brain puts it together and it sounds like one continuous tone. That's because that's how waves work, right? And there are wave patterns and stuff like this. It's a sine wave. If you're into math, I don't know what that means, but just so you know, right? So if you look at this, this is how it works. Going this way on the this axis, that's probably the y-axis, but that's, you know, that's a math thing too. And this might be the x-axis, or I could be wrong. That could be reversed. The point is, going this way, horizontal, that's the frequency. So every sound has a frequency. There are some sounds that we say are pitched, so that's like, this is a pitch. That's a C, right? There are some sounds that we say are not pitched. So a clap doesn't have a specific pitch necessarily, although that's not really true. It's just hard to like hear what that pitch is. So anyway, the frequency has to do with how many times per second your eardrum detects the sound, right? So the sound hits you in waves, so you can think of it as like an ocean wave, and then it goes back out, sort of like that. So it's how many times this happens, right? That's the frequency. The word frequency comes from frequent. Something that happens frequently happens repeatedly and often, and so that's why sound waves have frequencies, right? And light waves, I suppose, have frequencies. Any kind of wave, a microwave, has a frequency, probably. So, all right, then the up and down, like how high it goes, how low it goes in the wave, is called the amplitude. That's just for your information. So here's what we know, here's how it pertains to music. We have divided our keyboard, or our music notation, into basically 8 notes. They are the letters of the alphabet. So you can start down here. This is middle C, just for your information. I'm gonna go down here to A, right? And so we have A, B, C, D, F, G, A, and then we start over. That's called an octave because this has 8 notes. 1, 2, 3, 4, 5, 6, 7, 8, right? What I just played is not a major scale, by the way. It's just the note names, right? So that's an octave. Here's what I need you to understand. The A below middle C, has a frequency of 220 hertz, which means, so I'm going to do this, A equals 220 hertz, right? That means that you hear the pitch A 220 times. Actually, you don't hear, your eardrums detect the pitch A 220 times per second, right? Your brain turns it all into one sound, which is this, even though we know it's actually this. 220 times per second, right? Here's the thing. If you go up an octave, this is an A, this is also an A. The reason is because as you go up, the reason we stop here at our octaves, like when we were developing this, when we were Greeks, is because this is A2, I think. It's the A below middle C. Sometimes it's called low A. A3, I think, don't quote me. Is that right? No, this is A3. It doesn't matter. This is irrelevant. Okay. A3, the A below middle C, and A4, the A above middle C, are doubled in terms of their frequencies. So the A above middle C or high A is 440 hertz per second. So it's exactly doubled. So if you think about that, the sound is hitting your eardrums at essentially the same time. Higher notes have higher frequencies, like higher pitches have higher frequencies. They hit your eardrums more often. So if you think about it this way, you can create a graph. So let's say this is 1 second, okay? And we know that A3 is 220 times per second, so let's pretend that I put 220 X's here. Each X is the point at which the pitch hits your eardrum. This is pretty fascinating stuff, right? But A4, the higher frequency, hits it at double that. So if you start, these two, A3 and A4, line up here, then there's another one here. And what that means is, because they're exactly double in terms of frequency, that means every other time the sound wave hits your eardrum, they line up, right? So that's why they sound like they're the same tone. They're not, right? They're two different pitches, but A4 is exactly double. Then if you're talking about like creating harmony, right? If you're singing or playing or whatever, if you take a fifth, so here's A fifth is E, that's a perfect fifth, and that sounds pretty good together. We say that's pleasing. That's because I'm making this one up, right? I'm going to use dots instead of X's because I'm out of room, but essentially, let's say it's about a third. So that A and E hit every 3 times together, right? They're together every 3 waves that hit your eardrums. Yeah, so that's why they sound together. This doesn't line up at all, right? The frequencies are too dissimilar, so we say it clashes. That clashes. That's a minor third, it's a little better. That's a major third, that sounds pretty good. Fourth sounds okay. Fifth sounds good. Sixth sounds okay. But anyway, so that's how that works, yeah? Frequencies and note values. I think that's all I wanted to say for today. That's just how sound works. There's some science for you. I hope you understood that. All right? Last thing, yeah. So between the intervals, or between the octaves, I mean, we have 12 tones. 12 tones, that's the chromatic scale. Those are half steps. They're also called semitones. So the reason it's divided up that way is because we can hear that. We can hear the difference. We know that if I play this note and then I play this note, I go up a half step. There's a quarter step, right? If your ears are really well trained, you can hear quarter steps. But what you would really just say is, here's a C, and if I hear a quarter step, it's in between these two notes. And what you would just say is you're singing or playing a little sharp there, right? Sharp means higher, flat means lower, a half step or like a quarter step or something like that, right? So that's just how we've divided it up. 12 half steps or semitones in an octave, right? I think that's all I want you to know right now. So there you have it. Play around on your instrument.